So today we are recording another mock interview, and in this interview we'll take few minutes to present a solution for the problem that we asked in the previous interview. So it's a slightly different solution and a bit like looks interesting as well, so that you also get to know about different solutions. So the last time the question was that how do you swap adjacent bit in a, digit or a given number. Let's say you are given a number n. How do you swap the adjacent bit starting from the zeroth? So the answer would to this example would be 0x 01 11 10, right? I think
Okay.
this is the answer.
For clarification, let's remove 0x. These are binary bits, not
Yes.
hexadecimal.
Okay. 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 I should have been 0b instead of,
0b.
yeah.
Yeah.
Uh,
Okay.
yeah. So answer to this, there was another solution to this question was that let's say that you are given this n number, and what you do is you uh, you know perform an AND operation with this n, uh, with an another, let's say 0x a, right? So that means like you are trying to uh, eliminate all the even bits, all the
Even bits.
even position bits, yes, right? So this is for a, right? So what I typically did was that, let's say if n was all ones, then what I'm trying to do here is that 10 10 10, this is what I'm doing, a 0, right? So if I do end with 0x, like all the a's, right? This is the output that I'm getting, right? So I'm selecting the even bits here, and then if I do the end of given this n with 0x5555. So now I am selecting all the odd bits, right? So it should result into 0 1 0 1 0 1 0 1, right? So if you think about it, then we can understand that in this operation we extracted out all the odd bits, and in this operation we extracted out all the even bits, all the odd bits, right? And if you slightly move this to this number to 1, then what you essentially get is this number, uh 0 0 1 0 1 0 1, right? And if you slightly move this to a right, what you get is 0 1 0 1 0 1 0, right? And if you perform the OR operation between these two, so what you essentially get uh, is the swapping of whatever a initial number was, right? So this is how you typically perform, uh, you know you can swap the adjacent bit, and then the operation would be like this, just a single operation of and uh, like a, and then if you perform a OR operation with another 0x 5555. Typically I'm assuming that n is a 32-bit number. uh, in this case this is the case, and what I can do is to right shift it with 1, and then this is left shift it with 1. I think this should be correct one. Let me. Yes, I think this should be the correct solution, right? I essentially returned this one. Rajat, do
I,
you see any problem with this?
yeah, you may need another parenthesis at 0x after 0x 5 5 5 5
Okay. Yeah, here. I think I can remove this and this one. Okay. Yeah. Okay. So like instead of going through a bunch of operations, you could do this within a single line. So that was the essence of this solution. And now let's start with the interview today. So today Mohammed will be our interviewee, and I'm going to ask him some questions. So the first question here is that they calculate the size of a structure without using a size of operator.
Yeah, okay.
Yeah,
All right. Yeah, thanks for having me here. By the way, first, for the first solution, we would like to thank, I think there was a comment which mentioned about this
yeah,
solution. So yeah, with maybe you can pin that comment to the last video,
yeah,
and if anyone wants to have a look, they can.
yeah.
Okay. Yeah. So yeah, moving on to the question at hand here. Uh, Calculate the size of the structure without using the size of. Okay. Hmm. And here I'm not given any info about like the contents of the structure, right? The definition of the structure. So to say.
You can assume it any structure.
It's
Yeah,
any structure,
You can
and
create a dummy structure
and
if you want.
but my uh, so the reason I asked the question was the solution has to be generic so that it can work on any structure,
Yes.
obviously, right? Okay.
right,
So you can
Hmm.
assume that your structure looks like this.
right.
Fair, fair. Okay. By the way, Rajat, your voice is being kind of.
Is
It
it
feels like
still
it is
not
sped up, and now it's better. Yeah.
okay?
Okay, cool. Uh, okay, so we have this structure, and I want to find the size of this. Hmm. Okay, I'm thinking maybe uh, you can use some pointer arithmetic uh, to my aid here. So
Mhm.
uh, okay, I can maybe uh, create a pointer uh, to an element of the structure, right? Something like uh, let's say struct student one pointer p equals struct student pointer, and let's say we had an element here somewhere, uh, std1 something student one. So this is the pointer. Now what would happen if I increment this, right? Mm, so if I increment this, then it should point, like theoretically point to the next element of the structure array if there was one. Right? The compiler won't know, it would just increment it by that size. So I should get the size of the structure by that trick. Mm, does that sound right to you guys?
Okay.
Okay.
If you, yeah, so just a comment. If you're trying to be syntactically right, I think
Hmm.
std1 needs to be declared.
Oh, it's here.
You didn't create.
Here,
Uh,
here.
Yeah, but you didn't define it. It's a declare. It you didn't define it. No memories.
No, this
That's just the
is
name of the structure, right?
no. Student is the name of the structure. std1 is the instance.
Okay. Yes. Okay. It's not
Hmm.
type def, right? Okay.
It's not
Hmm.
type def. Yeah. So struct student p. So this is my p, and I'm initializing it to std1 here, student one instance. And now if I do, let's say p plus plus, so this has moved to a size which is, you know, this has moved to an address which is uh, the diff, or rather the addition, the addend would be the total size of the structure here. That's what I mean. And just to be, uh, clear what I mean, let's say I do another pointer p2, say, sorry, p2 equals p plus plus, and I can print maybe the size of struct as percentage d. Here it could be, character pointer. So I'm typecasting it as a character pointer to make sure I print the size in bytes, minus character pointer p. I hope this works.
Okay.
Hmm.
See any issues here?
I think it should be correct.
Are you getting the address here?
Oh, yeah, yeah, you are right, man. Yeah, that's an important point. I didn't.
Uh, hmm.
Yeah. So this would give all sorts of. I don't know what it would
Yeah.
result in. So the idea here is, for our viewers, the idea is, just assign a pointer with with an instance of the structure. So it would point anywhere in the memory, and we basically use the power of pointer arithmetic. So we
Hmm.
increment that pointer, and what would happen is the compiler would allocate uh, the new address for this p2 appropriately, having calculated the size of the structure, because we have typecasted it properly here. It, and also the type of this new pointer is struct student pointer, so it would allocate the appropriate size and increment it by that amount, and then we
Hmm.
just calculate the difference to get the size.
Okay.
And what would happen is, I think this should also work for all types of structures, I believe, whether they are packed or unpacked, because the increment would take care of that.
Okay. So, do you really need this typecasting here in this line 52?
Not really, because yeah,
Hmm.
I don't think it should be needed, because I'm already declaring the pointer to be of correct type, and
Hmm.
I'm deriving the address from the instance of that type. So
Hmm.
not really needed. So it could be just, might as well be this.
Hmm.
But I think this
Okay.
was more readable.
And
Yeah.
what would be the size of this, let's say, p pointer or p2 pointer that you created here?
The sorry, what size of what
Like
now?
both the pointers that you created here, what would be the
Okay.
size?
So you mean the like this size of P2?
Yes, yeah.
That's what you're asking? Okay.
If that's
Well,
the way you calculate the size of a pointer, then yes.
yeah. Okay. Cool. Got it. I think that that would depend on like the architecture of the machine
Hmm.
because generally, let's say for modern machines, it should be 8 bytes.
8
Like
bytes.
yeah, because the virtual memory is what 64 bit long,
Hmm.
so it should require 8 bytes to store that address. But
Hmm.
having said that, it should depend or rather vary from machine to machine.
Okay.
Okay.
So what we mean is that based on your architecture, it can either be 16 or 12 bytes. So
16,
16
12.
in case you are a 64-bit architecture, then it will be 8 plus 4 plus 4.
No, he's
No.
asking the
No.
question for just the pointer.
Yeah. Not this
Okay.
struct. Yeah.
Okay.
But yeah, you are right that if the uh, and you are asking the question what will be the size of the structure, then it could be yeah, because this would this can theoretically occupy at max 8 bytes,
Hmm.
right? And this would be 4 and 4, so it would
Yeah.
be again 8 plus 4 plus 4, that is 16.
Hmm. Okay. And like,
Mhm.
so the one question here is that why do you really need this character pointer? Like, is this conversion required in line number 5 5?
Line number 50. Oh, you mean during the inside the printf
Right.
this character point?
Subtraction.
Hmm.
Like, I just want to know, like, what is the idea
Yeah.
behind?
So
Like,
yeah, that's a good point. So what I believe, actually, I might be wrong here, but what
hmm.
I believe is that if I have not done a typecasting into character pointer, so let's say we just have this, right? P2
Hmm.
minus P2
P1.
minus P, let's see. Then this should return me 1. And the reason is that, the arithmetic would also work in a way where it would just give me the difference of like the elements basically. Like how many, struct elements are there in between.
Okay. So you
So
will get answer -1.
minus 1?
Yeah, because P2 is ahead. Okay. No, right?
Yeah.
So you should get
So
a
I would
answer
get
1.
1, right?
1.
Yeah, that's what. So I don't want that. I want the size in bytes. I don't want the size in the number of elements. So let's say we had this, right? P plus 3 or 2 here. If this was the case, then this line here would print it as 2, because P2 is like 2 structure elements ahead of P.
Hmm.
And pointer arithmetic would just give me how many structure elements it is ahead by.
Right.
So I wanted to explicitly typecast as character pointers, because then instead of counting everything in structure elements, rather here I would count
Right.
everything in terms of bytes basically. So
Hmm.
this would now, if I have, I think if let's say Control Z. Yeah. So if this is the case, this line is something like this, then this basically asks the question how many character bytes is P2 ahead of P, rather than how
Right.
many structure elements.
Hmm.
So
Okay. Got it.
this should all right.
I think shall we move on to the next question then?
Yeah,
Yes.
I'm fine. Okay.
Okay. So the next question is, how do you calculate the offset of a member within a struct? right? Let's say,
No.
usually you have an offset of operation
Mm-hmm.
in inbuilt library, right?
Mm-hmm.
But let's say you don't have that operation. How do you
Mm.
calculate, let's say, given the base address of, let's say, one of the instance of the struct, like struct student, and you are being asked that, okay, what is the offset of grade, which is one of the field in that struct student,
Okay.
right? With respect to the
Hmm.
base address of that instance.
Mm-hmm. Okay, so this is a bit trickier than the previous one. So in the previous one, we just wanted like the size of the entire structure,
Hmm.
and there we had the aid of pointer arithmetic. While here, hmm, I'm asked to find. So it's basically, so what the question now translates to, if let's say, hey, you know, if I break the structure into two parts. So if let's say the structure ended right before uh, the field in which I was interested in, then then I can just have the the approach of the first method which we discussed.
Right.
But
I
then
think if
that's not.
they
Mhm.
are allocated consecutively in the memory, right? Then yes.
That should be given, right? Uh,
Yeah. Like in this case, it is given, but let's say if you are, bringing the grade out of the
mhm.
struct, right? Then grade might be allocated somewhere else.
Fair, fair. But
Yeah.
then the question is, I need to find the offset of the member only, right?
Right. Yeah.
Yes.
So it will always be inside the structure,
Yes.
and
Yeah. Yeah.
it's assumable. Okay.
Yeah.
Okay. And here, can I assume that it is unpacked for now? Like, I don't want to pose any restrictions on, the
Yeah, you
Yeah.
can
packedness of
you
it.
can assume it is unpacked.
Okay. Okay. Hmm. All right. So
However,
I'm
that doesn't make
hmm.
a difference.
That should not. But for now, I don't want to, deal with
Yeah.
that
Yeah.
as well. But I'm thinking, if I can learn into the solution once, and we'll see if it also works for the packed structures on. So
Okay.
Sure.
that's I'm somehow trying to fit the previous solution into this one. Uh, but so one thing is clear to me, that straight away pointer arithmetic won't work here, because here we are not like looking at the structure as a whole. Uh, we are basically wanting to sort of seek info of an element which is within the structure. And one other thing, there might be some other more elements a structure
Yeah.
can have, right? And you are asking me, let's say, to find the offset of some element which is in the middle. So
Right.
there could be some, one or more elements above, there could be one or more elements below as well.
Yeah, I
Yeah.
think like the question is generic, that you could be even
Right,
asked
right,
to return the address, like the offset of the first element in the
right,
struct,
right, right, right.
but then
Or
that would be the same as the struct pointer base.
correct, correct, correct. Yeah, exactly, exactly. I'm just yeah, makes sense. I'm
Yeah.
just clarifying.
Yeah.
Okay, cool. Hmm. Okay, what if I take, so I'm just thinking out loud here, and mind if I use, this as a rough space as well. So,
Sure.
okay, maybe, same thing, struct student pointer temp. So let's say I'm, getting a temp pointer which points to this guy. And how do I do that? By the way, Here, do I know the data type of the element which I'm wanting to fetch the offset of?
No.
No, right? I just know the name.
Hmm.
Okay. And so let's say if I am given this API, then grade is like just the text, right? It is a string basically.
Yeah.
And what is
You can
student?
you can assume what we are giving you is student of grade and student.
Sorry, student of grade.
And student.
Oh, you mean like this?
Yeah.
Or dot?
Dot.
Dot.
Dot is fine. Yeah.
By the way, okay, this raises few more questions now. So this is a macro, correct? Or it's a function?
This is the function that you would want to implement.
Yeah, but then what I should take in as, because if it is a function, then I need to know the type of this field, right?
Hmm. Uh, I think you can use it as a macro, maybe.
Okay.
Yeah.
Okay, so it's a macro, then the
Hmm.
types don't matter because they
Yeah.
anyway are going to be replaceable.
Yeah.
So okay, interesting. So just a second, I think I'll do some more paperwork here. Offset. So generic definition of my macro would look like field, let's say, and struct name, something like this. So this should be the generic uh, way my macro is defined.
Yes.
And I want, so there is a structure with the name struct name, and I want the offset of the field type, and I don't know
Yeah.
the type of the data
Yeah.
type of that field. Okay, cool.
Yes.
Hmm.
Okay, so here let me do this then.
Okay,
Struct
I take it back. That should be grade, not student dot grade.
not student group. Yeah, okay.
Yeah.
That's
If I
I
give
think
you student, if I give you student dot grade, then the answer is very simple.
yeah, I just subtracted. Then there is no point. Yeah, it's like, so what by the way, folks, if you were following us, so what Rajat meant here was, if let's say if this was the definition, then the answer would have been like print f or return, uh, or not even
But
return, it would be
even in that case, you'll have to convert it into the addresses, right?
correct.
Yeah.
So character, it's basically the same line here,
Yeah.
subtracting, typecasting into character pointer and then subtracting.
Yeah.
Yes.
But then, like, you have to typecast the addresses, not the student directly, right? Like, can you write down just one liner for that as well?
Oh, I see what you mean. So maybe I can use a dummy temp, or so student is my, okay, maybe can we revisit this later? Uh,
Okay.
just I will do
Okay.
this. I think I get your point, Dev.
Hmm.
Uh, so you want, if let's say this was the definition, we want to also write the macro definition for this, even though it
Right.
is
Yeah.
very trivial, but we still want it.
Yeah.
Hmm.
But so we'll do it later. So I'll mark it
Sure.
as to do.
Okay.
Which, by the way, if you know, to do's only seldom get worked upon, right?
Yeah.
Yeah.
Okay, so offset of, now we have a field here, and I have a struct name with me. So I have a, let's say, struct student, or rather I will now use struct name here. temp, what I am going to do is again, following the same tactic, uh, assign it to some. mm, mm, do I need to assign it to any? It is a pointer. Yeah, I'll just go ahead and I will not be stringent with variables for now. Try to optimize it later. Temp and temp ptr is temp ptr. So I have now gotten a pointer to a structure, and now basically I need to do what? I need to typecast again character pointer. Just bear with me, folks. Pointer here. So temp pointer is already pointing to a structure named temp, and this is a field here, right?
Hmm.
So I have typecasted that, and just to be clear, I'll add as many parentheses to be unambiguous. Okay, and char pointer temp ptr. Am I correct in? Yeah. So this should give me the offset of the field.
Okay.
Okay, I think functionally it looks good to me. Can you guys confirm once?
Uh, I think there are few things that I can point out. The first one is, do you really need this temp struct to be explicitly created?
Yeah, I mean functionally, can you once verify whether it's functionally correct? Maybe I'll look into the optimization later.
Yeah,
Okay.
the ideology and functionality is correct.
Okay, okay. So
Yeah.
now let's go to the optimization part.
I think
Uh,
one more thing
Mhm.
that I need to point out here is that, do you see if this is going to find the correct addresses?
No, sorry, I didn't catch the question there.
So, do you think if this would result into the correct address of the field operation, like field?
Correct address of the field.
So essentially, let's say if if the field is at some address, right, offset,
Mm-hmm.
and do you think this would be, let's say, the base address was, let's say, 0x400, and then field was at let's say 0x8 offset, right?
Mm-hmm.
Then do you think this operation, the first this operation results into 0x408?
Mm, I would assume so.
Okay, so when you use this operation, what does that do? It accesses the field within that.
Oh, yeah, man. Yeah, you're right. Oh, I get it. I get it. So rather than that, I will have to. Oh, yeah, my bad, man. Sorry. I will have to again basically get the so dereference it and get the address of it. So I'll do this then.
Yeah, dereference was all anyway was done, right, as part of this operation, but then you needed to use address of that.
Correct, correct. Yeah. So
Yeah,
I get your point. Yeah, yeah. So dereferencing would now give me 408, which I then subtracted with the base pointer
right.
and get this. Or I could have done another way was, to do temp, because I already have temp here. Temp dot field, and this should also have worked.
Here you mean the temp here again in
Yeah.
this case. Okay.
Mhm. Temp is already
And
an instance, so
right.
I kind of access it and then dereference it
Mm-hmm.
and then typecast it to character pointer,
Mm-hmm.
which would give me 408, and then I subtract it again with the base 400.
Okay, and let's say that you don't want to create tmp,
Yeah, yeah. I
another
want.
instance,
Hmm, hmm, hmm.
and can you just deal with the pointer and
Pointer.
then make it
Hmm.
work?
Mm, okay, let's see what this gives me. If I don't do this, I'm just, thinking out loud.
Yeah,
This should also work, correct?
right,
Because here we are not actually. So the idea is that even though it looks like, we are manipulating some memory here, but during runtime we are not. We are just kind of,
right,
doing some magic so that compiler gives us the offset.
right,
So we are saying, hey, go to this field, but in theory there is no memory allocated for this field, but we are not actually writing or reading from it. We are just dereferencing it
hmm,
so that we get the offset, or rather the address of that field, and then subtract it with the base pointer. So
hmm,
we get the total offset,
right,
right?
hmm.
Okay, I think that makes sense to me. Now, is there any other way I can optimize? Uh, so I have been given struct name here and temp pointer. Um, Can I? I'm thinking of maybe combining everything into a line,
Hmm.
single line. Uh, mm, so I think this will. So if I, let's say I do this struct. Sorry, it is getting cluttered here. Temp pointer struct name temp pointer. I mean, I can do it in a line, separating by semicolon, so something like this. But seems
Hmm.
so. If I do this, it's. But I wanted to get, what I was trying to do was get rid of this and somehow make the definition also a part of this dereference. But
Hmm.
okay, I don't see any like direct way as of now.
Right.
Okay. Does this sound okay to you folks?
Yeah, I think it should be. Rajat, do you have any other expectations apart from this?
I think this looks okay.
Hmm.
Okay.
So,
And yeah, let me then jump to the to do part.
but
So,
but
mhm.
what does temp pointer points to
Temp
here?
pointer doesn't point to anything.
Yeah.
That's the beauty.
Hmm.
Are you sure it will be right?
Oh yeah, yeah. I have to make it point to some. Yeah, you are right.
If it
You are
is
right.
not pointing to
Not pointing
anything,
to anything.
it's it is not gonna work, right?
Yeah,
Because there is no
yeah.
address to
There is no
access
address.
field to.
That's totally true. It's totally true. So what if I make it point to some dummy memory? I don't care, right? Uh, because ultimately I'm just after the difference and not the actual memory. Whether so my worry is not that whether hey that memory is accessible to me or does it even exist in the system or
Hmm.
all of that crap because we are never going to actually access the memory. So what if
Hmm.
Okay.
I uh, maybe I'll can think of any number. Let's 100. Why not? Doesn't matter. And I just typecast it here. Struct struct name pointer. Struct name pointer. I'm typecasting this address to this,
Hmm.
and now
So
temp
do,
point.
do you really need to do some initialization before accessing this, because it's all compile time, right?
Sorry, what initializing?
So like, do you really need to do this initialization of the temp pointer? Because what I see is that these all these operations are at compile time. So uh,
Right, but then I don't want compiler to crib about the typecasting
uh,
errors, right?
So even if it is compile time, the
Hmm.
pointer should point to something.
Point to
okay.
so I think Rajat's
In
point
that
is there
case,
that temp pointer will be like, hey man, this is not initialized. So
yeah, I
uh,
think the compiler might warn you, right?
uh,
Or it would be an error. It should be warning only.
oh, so okay. So just for the
It
context, we
it,
are.
it will silently, depending on what time pointers
Hmm.
value was assigned to in stack. It can crash. It can do whatever it wants.
It would not crash because like this operation does not exist in the runtime, right? This is just end up with just a numeric value, which is 0x8 or 0x4, right?
No, it would be. It won't be compile time only. It would be done at runtime.
Which one
Yeah.
like this? So since this is a macro, right, this
Yeah.
should be all compile time.
No, no.
No.
Macro would
Macros
be
are
replaced
will be
with the
expanded,
content.
right?
Expanded.
They
Yeah.
will be just expanded. They will be just pre-processed. All the
Hmm.
compiler is still gonna generate codes for them.
Hmm.
Okay.
So
So
I think I let me write the. So we are
Hmm.
compare just to set up the context. This is solution one, right? And solution two was we don't basically initialize and just do this instead of this, right? It is
Hmm.
right. So our now our debate is will this work every time versus compared to solution one,
Hmm.
right?
Yeah.
So agreed with you, Dev, that so this is like offset of whenever in whatever place we use this offset of macro will
It
either
would be
expand
replaced
to
with this.
yeah will
Yeah.
either expand with solution 2 or solution 1
Right.
hmm,
now. But then this all my belief is that all the operations, right, this the
Hmm.
subtraction, the dereferencing in some form, dereferencing in some form would happen
Hmm.
at runtime.
Okay. I think the compiler can also optimize it, right? Since it's just,
That
I
may
mean,
be possible. Yeah,
if it figures
I
out that.
wouldn't. True, true, true. I
Hmm.
wouldn't put that past the compiler. So
Right.
if let's say that uh, it also has the access to the definition of the structure,
Hmm.
it can it? But here, okay. So tell me this: what does this? How can compiler understand this? Right? Temp pointer field. In our case, where we have not initialized it to anything,
Hmm.
like what would this be resulting?
I think
At,
this would result to the offset uh, of that field. Like not the offset, it would result into the address of that field, and
but what?
that
So
is
in your
subtracted with
case,
the temp, so it should just
no.
respond to
But
it.
in your case, you started off with the assumption that 400 is the base. Now, how
Right.
did you land to that 400 number?
So this
Because
number temp pointer will anyway have some garbage value, right? Maybe.
that is
Okay.
at runtime, right? Not at
Runtime.
compile time.
Anyway, I think this instead of debating, I think we can
Maybe we can,
solve.
offline see if it even compiles.
Right. So
But
it
I
it
think the
the problem can be solved by just initializing it with null. That should work.
yeah, exactly. So instead of 100, it could be 0x0 as well.
Yeah.
It could
Yeah.
be anything basically.
Yeah.
So we
Yeah.
are after the offset and not the actual value. But man,
Yeah.
this is interesting. I am going to try to compile this.
I
Just
think in my case it should. I guess.
and if let's say if it compiles, then Rajat, it's fine, right? Even though it is
Yeah.
garbage, it is anything, it doesn't
Right.
matter.
It compiles. It compiles. It works as well.
Wow, okay.
Ah. Okay.
So both, well, learn something new.
I
Well,
think this
the
is all compiler thing. I guess it would
Yeah, yeah,
just
yeah.
get
yeah.
to the offset. Yeah.
So ideally, you don't even need to do all of this.
Mm-hmm.
You can use zero as a reference and
Yeah,
Yeah.
like this, right?
so yeah.
Hmm.
Hmm.
So I think what actually happens is, so even though the preprocessor processes it, generates a code, the compiler sees all of these as a constant code.
Hmm. No, but
Hmm.
I'm really interested in this, man. Like, how does this compiler figure this out at compile time? Tell me. Like, you have not initialized it to anything, and I'm finding it very hard to believe that it is
So
done at compile time.
it can be right. It knows the type of the structure. It knows what it points to. It can calculate everything. Since all of the parameters that it nodes can are known at compile time, it can calculate the difference at compile
Different.
time.
That is fine. That is fine. That is fine. But let's say, okay. So, had I not done this, then what would have happened?
Then it will not work.
Then it won't.
Hmm.
So I find it very, it's very intricate that just adding the dereference compiler knows, hey, I don't need to depend on anything. I can just go ahead and get the answer for you. It's very
Yeah.
intriguing. I mean,
Do we
Well,
have time?
if you don't put the dereference, you are actually not getting the address right.
not
Right.
You're
getting that
just you are actually trying to dereference
a feel,
a
but
pointer
oh,
that
oh,
never exists.
don't yeah, yeah, yeah.
Hmm.
So,
I think somehow the compiler clubs these two operations into one, and then say, okay,
hmm,
this is some address. Like this was supposed to be the value to that field, but then since it already knows that there is an ampersand, before that, so it
fair,
would
fair.
essentially result into the
The
address,
address,
right?
and it
Yeah,
doesn't
but
even care what the
Huh.
base is. It's
Basis,
like
yes. Hmm.
it may be theoretically behind the hood. It might be starting at
yeah, it
zero.
might be
Who knows?
putting everything.
Yeah.
Yeah.
Yeah, but I think on a safe side, I think the solution one is much better.
Hmm.
Yeah.
to be on
I
safe
think
side,
just
not to assume what compiler is doing.
Hmm. Yeah,
right.
yeah.
Just put null in the front
So
of the
let's say
pointer.
compiler is written by someone like me, then better to go with solution one.
Yeah,
Okay.
and I'm not sure. Maybe we need to search whether C standard guards this or not.
Hmm.
This
Hmm.
like from the logic of it, this looks to me like a compiler magic and
Hmm.
Yeah. I
compiler dependent behavior of C.
Hmm. So I
right.
think standard might not have any,
Yeah,
well, any notion of what it prefers. It's like, hey, do
yeah,
whatever you want, right?
Hmm.
yeah.
Okay. So do we have time left, or we can close down the
What's
interview? I don't see the timer here
okay?
on my screen.
I
We
think
are down to 45 minutes.
we can close
Okay.
it.
Close it
Uh,
then.
yeah. I'll just want to expand the to do thing then. The to do becomes much easier now, right?
Okay. Yeah.
It's same lines, same lines here. And since I'm given the field here, I just do this.
Yeah. Instead of this, you are given this only, right?
Yeah.
That's the one.
No, no, student dot grade.
Ah, student dot grade. Okay.
So I just do this and temp pointer. Correct.
Hmm.
If there is
Ah.
some, so it becomes a bit easier. Don't have to go to the field and do it.
So
Then
basically, I'm just passing you the
Hmm.
addresses of. I'm already passing.
address,
I'm
yeah,
not passing you student
right.
dot grade. I'm passing you ampersand of student dot grade.
Okay, then it becomes even more easy. Like I just subtract and return.
Yeah,
Okay.
Hmm.
exactly.
Then why
But
do
So
you even have a macro, man? You just
yeah,
do it yourself.
so that's why I said let's forget it.
Yeah. Yeah.
Okay, I guess
Okay.
the
Great.
last question is
okay.
very small. We can go through it very quickly.
Okay.
Okay.
Yeah, I think it's a very nice question, and so just predict what will be the output
Oh
of this
yeah.
code.
Hmm.
Yeah.
Hmm. Interesting. I see pointer sneakiness here. Hmm.
I think we can leave this question to the viewers to come, a response in the
Hmm.
comment,
Maybe.
maybe.
Yeah. I know.
Yeah.
Maybe we can take up as a a
Follow
starter
up.
solution in the follow-up video. Yeah.
Yeah.
I know.
Or let's do one
Okay,
thing.
guys. So I think
I
it's
like Dave's idea. Let's drop it, and in the next video we'll start with this question and discuss the
Yeah.
solution will be. Why
Yeah.
not the
mm,
audience solve this question and put in the comments?
Yeah.
right.
Awesome.
Okay.
Cool. Okay. If you guys stayed until now, thanks. We'll be back with the next one.
Yeah.
Okay. Bye bye.
Bye.